Hello and welcome. In this video tutorial, I will demonstrate how you can create box plots in the KIWI ExploreLive module. I will illustrate the use of basic settings, such as the selection of your data source, selection of the variables that are displayed on the box plot. I will also illustrate the use of more advanced settings. Here I have an active ExploreLive session in which I have already uploaded a dataset. This is a simulation pharmacokinetic dataset called demo.csv. I have used this dataset to create two modified datasets. The first one is called 1 per ID, and I have just subsetted the original data to the first record per subject. The second dataset is called data 10, and in this modified dataset, I have just subset it to the record with those equal to 10. I will use both datasets to create box plots, and for that, click on the plot menu and select the box plot item. As usual for plot submodules, the interface displays a pretty large plot panel where the actual plot is displayed. Once the appropriate selections were made. On the right side, we see a data panel, and it's where you select the source data for your box plots. The first field is where you actually select the data set, and this field will show all the imported data sets, any modified data set that you would have created in the data module. And if you have merged or pooled two data sets together, the pool data would show up. I will start by selecting the 1 per ID dataset, and I will create a first box plot by selecting an X and a Y axis variable. A typical box plot shows the distribution of a continuous variable. So your Y variable, I'm going to choose the weight variable, WTKG. And so that's the distribution of this variable against the value of a categorical variable. In this case, I'm going to choose my study C variable. This is a character variable with 3 different values, reflecting 3 different studies in my data. So a box plot is generated for, or a box is generated for each of the value. And the design of that box is it's box and whisker. Actually, the design follows the original design proposed by Tukey in the 80s. A box and whisker include a median shown as a line if there is no data stratification. It could be a symbol if stratification is used. I'll show that a little bit later. The box delimits the first and the third quartile of the data. So that's the 25th and the 75th percentile. The box also includes by default a notch. That notch represents approximately a 90% confidence interval around the median, and it's mostly used to compare median values across boxes. So if the notch, the interval delimited by the notch kind of overlap, you know that those two medians are not statistically different. Beyond the box, you can see whiskers extending above the box and below the box. These whiskers are not based upon percentiles of the data, so they don't delimit, let's say, the 90% confidence interval of your data. They're actually based upon what is called the interquartile range, or IQR. This is the difference between the third and the first quartile, so literally the height of these boxes. So this IQR is used, and a multiple is applied by default. We use 1 times this IQR, and that value is added to the third quartile, and the last data point within or lower or equal to the third quartile plus 1 IQR is the limit of the whisker. So again, this value, the third quartile plus 1 IQR, delimit an interval. The last data point within this interval is the limit of the whisker. So this whisker is literally a data point. The same way for the bottom whisker, we take the first quartile and we subtract 1 IQR. The last data point within this interval delimits the whisker. Any data point beyond this, the whisker is displayed as a point, and could be considered an extreme value or an outlier, depending how you're thinking about the problem. So that's the basic default box and whisker design. There are a few things that you can customize in the basic settings panel. You can increase or decrease the whisker limit by changing the multiplication factor. 1.5 is a multiplicator that is used oftentimes. It's not exactly a 95% confidence interval, but it's, when you have a lot of data, is roughly that. You can decide to hide the notch by clicking no on the show notches field. That will just collapse the or show nice rectangular shape box. And you can also choose to show all the data points, and not only the data points that are beyond the whiskers. You can show all the data points just to get a feel of the distribution. So jitter is a random jitter is added, so you can view how those data points distributes in the range of data. Those are the simple design elements that you can change. You can apply some stratification on your data by selecting a color by variable. I will select a categorical variable, gender or sex, and in this case the box are now colored, and you get 1 box per value of your color by variable, and also per value of your x-axis variable. There are a few things that you can also define in the advanced setting box. You can have a control over the axis. You can provide axis title that is not default, so some custom label, and replace the name of the variable by your custom text title. So now I provided an X and a Y axis title. In the case of this type of box plot showing continuous variable versus categorical, you're not allowed to change the x-axis range, because it does not really make sense for a categorical variable. But you can zoom in, for example, your y-axis variable. So here I'm going to select a 50 to 100 interval. And you can see now that you're zooming to this particular interval of weight. You can also add some reference lines if that's needed. You can include one or more horizontal line. So you need to provide values separated by some commas. So I'm going to use 50, 70, 85. And you can see that the lines were displayed in the background, so behind the box. The same way you are not able to provide an x-axis limit, you cannot use vertical lines when the x-axis is categorical. So if I type a value here, an error is displayed in place of the plot. So why do we have an x-axis limit and a vertical line option? Is because you can actually create box plots showing the distribution of a continuous variable against the value of a continuous variable. So for that, I'm going to switch to the DOS10 data. As soon as I switch my data set, all my selections were reset to default. So here I'm going to select a continuous time variable, so TSFD, and I will show the distribution of observation contained in the DV variable. And so that the data contained in DOS10 was essentially phase 1 data where measurements were obtained at the same time point for all the subjects. So what you see here is a box and whisker for each sample time. And the concentration decrease over time. So in the case of a continuous x-axis, you can actually zoom in. So I'm going to use 0 to 10. And now your axis is set to the range you've defined. And you can also add some vertical lines if that is necessary. So here I'm showing something at 7. So this is sometimes useful to see a distribution of an endpoint over time. Instead of using a scatter plot design, you can use a box plot design. I'm going to switch back to the one per ID to talk about the some other advanced settings. I'm going to choose again my study and my weight variable. I will color by dose, and dose is a continuous variable in these data sets. So I have to categorize it, and I can do that by going to the data panel and select dose in the second field. Now dose becomes a categorical variable and is used to stratify. So the width of the box in the case where your stratification variable is not so if all the variables of all the values of your stratification variables are not in all the values or present in the values of your x-axis, you end up with boxes that are slightly larger when you have less groups of your stratification variable. Especially here, we only have one. So we got some boxes of different width. The plot panel in the Boxplot submodules also provides some interactive features. So if you click on a data point, this data point will, the design of the point will change, and information about this data point will be displayed in the selected panel that is shown. By default, we're reporting the value of the x-axis variable and the y-axis variable. But you can add additional information if you need to, for example, identify the subject associated with this data point. you can add the ID variable or any variable that would make sense in your particular data. So in this case, I have a num variable, which is an index within a subject. So I would know in my data set that this would be the first record of ID 3004. You can go back to the plot panel and select additional data points. Their information is added to the bottom panel. You can also click on your mouse, keep the button pressed, and drag the mouse to create the selection area. All the data points in the area will be selected. In the data, in the selected data panel, you can see two buttons. The first one allows you to copy the content of this data set to your clipboard, and then you can paste this content into a spreadsheet like Excel or text editor to further process that data. The second panel is a reset button that will remove all the selection and hide the selected data panel. So I will click on this feature, this button, and you'll see everything being reset. Additional functionality, graphical settings. You can choose the slider to make the background lighter when you go towards 0 or darker when you go towards 100. Depending on your preferences and vision, sometimes you may want to change that. You can also change the graphical theme, so that is mostly impacting or influencing the color used in for the stratification variable. The two first themes, KIWI and KIWI Solid, are essentially identical. For box plots, they would differ for scatter plots. The last one is a theme provided by default by the ggplot2 package, which is the library, the graphical library we're using to create those plots. So some people are used to see this color scheme for GG2 plots. So you can use it if you want. Boxplots also offer some additional advanced settings that we have illustrated or demonstrated in other video tutorial. First, a concept of paneling was introduced for scatter plots. The functionality in Boxplot is strictly similar to what was described in this scatterplot video. I believe it's entitled Data Stratification for Scatterplot. Just briefly, if you choose a panel by variable, you get you break the data by panels, one per each value of this paneling variable. Another piece of functionality is the possibility to subset data inside the panel, inside the Boxplot submodule. This was described also in a separate tutorial video on data subsetting. Finally, you have the ability to download the plot. This is also something demonstrated in a separate videos. This functionality of download and subset and panel is essentially the same for all the plot types. So we have one video for each of those functionality. So this concludes our presentation of the Boxplot submodule. If you have any question, you can always refer to the KIWI user manual or send us questions at kiwisupport@cognitioncorp.com. Thank you very much.